Hello friends, welcome into our Sandeep Technical channels. Today we will discuss about that overhanging beams. At first, what is the overhanging? What is the meaning of the overhanging actually? The meaning of the overhanging beams, that means this is a simply supported beam if the some portion of the beam is extended beyond the simply supported, that is known as the overhanging beams. Here now let's start about the some example on the basis of the overhanging beams. Here this is our questions. These questions will be solved. Here a beam AB of span 3 meter overhanging on both sides is loaded as shown in figure. Determine the reactions at the support A and B. That means in these questions we will have to find out that reactions RA and RB. RA, that means point A and that point B. These reactions we will have to find out. Now let's start to solve these problems. Before the solving these problems, at first in these beams has given the UDL load. This UDL load will have to convert it into the point load. That's why that means 2 kilonewton per meter is multiplied with the this distance 3 meters. Meter will be cancelled, and 3 into 2, that will be 6 kilonewtons. That will be the 6 kilonewton about this point. That means center between the A point and B point. Now let us start that we take moment about this point. This point is C, and let us start. Moment about point C equal to 0. That means here reactions RA is trying to rotate this beam into the anti-clockwise direction. That's why we take it is a positive. That means RA multiply with this perpendicular distance about point C, it will be 1.5 meter. And similar types, this 6 kilonewton force is trying to rotate clockwise directions. That's why we take 6 minus 6 kilonewton is multiplied with the perpendicular distance about point C. That means 1.5 meter plus 1.5 meter, it will be 3 meters. And RB reactions is also trying to rotate anti-clockwise these beams. That's why we take positive RB multiply with the perpendicular distance about point C. That means 3 meter plus 1.5 meter, that will be 4.5 meter. And 5 kilonewton force is trying to rotate clockwise direction. That's why we take minus 5 kilonewton is multiplied with the perpendicular distance about point C. That will be 1.5 meter plus 3 meter plus 1.5 meter. It will be 6 meter equal to 0. Now we solve this equation. That will be 1.5 RA plus 4.5 RB equal to 48. Suppose this is a first equations, and now we take summation of Fy equal to 0. Fy, here Ra and Rb reaction is applied vertically upward. That's why if we calculate, this is a positive, that will be Ra plus Rb, and equal to this force is applying vertically downward. That means it will be 6 kilonewton plus 5 kilonewton, that will be 11 kilonewtons. And this is a second equation. We solve these both equations. Ra equal to 11 minus Rb, and that value we will put into the first equations. That will be 1.5 Ra will be 11 minus Rb plus 4.5 Rb equal to 48, and this will be 1.5 meter multiply with the 11 meter, that will be 16.5 meter, and minus 1.5 Rb plus 4.5 Rb equal to 48. Then if it will be 31.5, and Rb equal to 31.5 is divided with the 3, that will be 10.5 kilonewton meter. This is a first reaction. We have calculated Rb value 10.5 kilonewton, and this value we will put into these equations. Here Ra equal to 11 minus Rb value is given 10.5, and that will be 0.5 kilonewton meter. This is a problem solved, and thanks for watching this video.